Welcome to the skeletal system. We're going to do this a little bit different. I'm going to give you the overview, and then we're going to go into the lab and actually look at the bones, kind of like what we did with the tissues. But we're going to go from the top of the skull down to the toes, and we're going to go over those bones. So first of all, we're going to do this overview. This is an organ system. It is composed of a lot of different tissues: bone tissue, cartilage, dense connective tissue, blood, nervous tissue. So it is a full organ system. It is alive. It is multifunctional. Most of us realize the skeleton, we need it for movement. We need it to protect our softer tissues, our major organs. It is our bone marrow where blood cells are formed, and as I mentioned, it is the storage of several minerals. So the skeletal system has two divisions, the axial and the appendicular skeletons, and we will look at those separately because it's just easier to do it that way. First, we want to look at bone shape and structure. The bones vary a lot, is all I can say. There are all kinds of different sizes, all kinds of different shapes. There are some generalities, and so the bones are similar in terms of their internal structure, the way they develop, and their function, but they all look, different. So we classify them according to the shape and the structure. We have 6 basic categories, which are these flat bones, basically the bones that are sutures. We'll talk about that. The long bones, the irregular bones, the sesamoid bones, and the short bones. So the flat bones are obviously flat. These are the bones in the skull, primarily in the rib cage, in the ribs, what we call the shoulder blade or the scapula. They're going to protect these underlying soft tissues. Think about your head connecting that skull, connecting your brain. The rib cage connecting the heart and the lungs. They do provide a pretty good surface area for some muscle attachment for the skeletal muscles. So we'll take a look at that. The sutural bones, these are irregular bones that are formed between the cranial bones. It depends on you, the size, the number, the shape, but you can see it right here in between these two bones. All right, so you can see the flat bone. You can see this, and again, we're going to go into the lab and we're going to really look at these. Then we have the long bones, our arms, our legs. These are relatively slender. And then we have the irregular bones, and these are all kinds of different shapes again. The vertebrae, the bones of the pelvis are facial bones. So these are very complex shapes, very just different irregular shapes. We have sesamoid bones. These are small flat bones. Yes, sesame seed. I don't know if I kind of agree with that, but they call them a sesamoid bone. They develop inside the tendons of the knees and the hands and the feet. The more famous one is the patella, which is our kneecap. And then we have short bones. These are little small boxy bones. Again, these are going to be the bones of our wrists, the carpals, and the bones of our ankles, the tarsal bones. All right, so let's look at a long bone. And you can see the names, the parts of this. You're going to need to know a lot of these. But you have the end, which is the epiphysis. And then you have the shaft of the bone, the diaphysis. You have cartilage covering this epiphysis. You have periosteum, which is connective tissue, this dense connective tissue which encloses the bone. We'll talk about compact bone and spongy bone. And we're going to look at the trabeculae, which is something that is in the spongy bone. And then we have that hollow chamber in that bone, that hollow cavity that contains the bone marrow. That's the medullary cavity. And then we'll talk about the endosteum, which lines that cavity, and then we'll take a look at the bone marrow. So the main thing with this is we have the epiphysis area, which is, we'll talk about this. This is where it grows. This epiphyseal plate, if the bone is still growing in terms of you're still growing in height, this is where a lot of this is going to occur right here on this line. All right, and then you can see the parts of the bone. So let's take a look at this. So the epiphysis, this consists of largely of spongy bone with overlying compact bone. Spongy bone can be called cancellous bone. It can be called trabecular bone. It has several different names depending upon who wrote the anatomy book. So don't be confused if you hear, cancellous bone, trabecular bone. It's still the spongy bone. Okay. So what you look at is, and we'll look at this, but the hard outside of the bone, and I've got a real good picture of what the bone looks inside. That hard, real outside of the bone is compact bone, and then the inside where the marrow is the spongy bone. And the epiphysis is that upper layer, that outer layer up here on that bone. So if we have a long bone, this is the shaft of it is the diaphysis. Then you have a middle section, metaphysis. I talk today. And then you have the end, which is the ends of it, which is the epiphysis. Okay. And you do have cartilage that covers the portion of the epiphysis where it is meeting some other bone, and because we are articulating or touching, is called the articular cartilage. All right, so the diaphysis, the shaft, contains that medullary cavity. As we said, that's the cavity where the marrow is, and is filled with two types of marrow: red bone marrow and yellow bone marrow. The red bone marrow is what makes our blood cells. The yellow bone marrow is fat. It's adipose tissue. This is an energy reserve. Basically what happens is when you're young, you're going to have a lot of red bone marrow because you're growing, and by the time you're about 20, you've replaced at least half of that bone marrow with yellow bone marrow. So by the time you're an adult, you're starting to move the red bone marrow out to the yellow bone marrow, and letting that take its place. And you don't really need it because, again, you're not growing and growing in height and that sort of thing. You're just when you've reached your adult height, you're just repairing, and you're replacing the red blood cells as they age out. These blood cells as they age out, but it's not going to take as much as if you're aging, replacing bone cells that are the blood cells that are aging out, in addition to trying to grow. So once you reach about 20, you're going to replace about half of that red bone marrow with yellow bone marrow with the fat. All right, so let's look at the microscopic structure of the bone. And we'll be taking a look at that in a second in a picture. But you have, first of all, the bone cells, osteocytes. Okay, and as we said before, when we looked at the bone tissue, we said they occupy this little pocket, if you will, this little chamber called a lacuna. And we have these passageways where the cell processes can exchange nutrients and waste. There's caniculi. And then we also have a matrix. The matrix of the bone is collagen fiber and these inorganic salts. Okay, primarily composed of calcium. But the collagen gives you the bone resilience, and the salts makes the bone hard. So osteocyte, bone cell. These are the mature bone cells that can no longer divide. We'll talk about the earlier cells, which are called osteoblasts. But the osteocyte is a mature bone cell. It has basically formed, it's not going to divide anymore. It occupies that little pocket, the lacuna, and is separated by the layers, the lamellae, and they are interconnected by the caniculi. All right, so bone formation, the formation of bone is hematopoiesis, hemopoiesis, same thing. A lot of people use the hemopoiesis or hematopoiesis. But this occurs in the red bone marrow. The red blood cells, white blood cells, the platelets are produced there. Again, with age, this is replaced by fat, and that doesn't produce the blood cells. So the red marrow remains in the adult, in the skull, and the ribs, the sternum, but a lot in the hip bones. In fact, if you're going to have a bone marrow tap, they're going to go into the hip bone because you can get a nice sample from there. Bone marrow transplants are used to treat various cancers, and this is very easily actually done. You just collect it and you can infuse it. You can infuse it like a blood transfusion. This is a place where we store inorganic salts. About 70% of the bone matrix is consisted of salts. It is most commonly this calcium phosphate. You can see these other salts, but this is primarily what gives us the hardness. If you have bone loss, it's called osteoporosis. The amount of calcium that is in that bone is regulated by 2 hormones. You'll get this in AP2, but it is the parathyroid hormone produced by the parathyroid gland. These are in your throat, and calcitonin produced by the thyroid gland. Parathyroid hormone increases the amount of calcium in the peripheral blood. Calcitonin lowers it. And so you just basically, we'll talk about, you either are storing calcium in the bone or releasing it into the bloodstream when the calcium levels get low. So if the calcium levels are kind of a little bit high, you'll store it in the bone, and when your calcium level gets low, you're going to break up bone and release some of that calcium out. Okay. So, when we look at bone development, the parts of the skeletal system begin to develop a few weeks into the prenatal development, and they will continue to grow and develop until your adulthood. The bone forms when the bone tissue is replaced in 2 different ways, what we call intramembranous bones and endochondral bones. So when the fetus is at about 14 weeks, they show growth of both of these types of bones. The intermembranous bone, or what the process we call intermembranous ossification. This is in the flat bones, the clavicle, the sternum, the facial bones like we talked about. And these bones form from sheets of connective tissue. Versus the endochondral ossification, chondra, again, cartilage. So this is going to be in the long bones. Most of the skeleton and the bone is formed from hyaline cartilage. Okay. And you can see some of this development of the bone here. So the intermembranous bones, you have the sheet-like layers of connective tissue, and they are laid down. In terms of the ossification process, you have these primitive tissues differentiate into what we call osteoblasts. Osteoblasts, when you hear the term blast, that means it's an early cell, whatever kind of cell it is. This is an early cell, and the prefix in front of the word blast means this is what it's differentiated into. So we start with the very, 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 very primitive cells, stem cells, and then as they begin to differentiate into whatever they're going to become, we put that name in front of it. So osteoblast means these are very, very, very early cells that now going to become bones. Okay. So the osteoblast is going to deposit bone matrix around themselves. And then the blasts, when they're completely surrounded, they are now in that little pocket, in that little lacuna. And they live in there. Okay. And you can take a look at this picture. The endochondral bones, again, begin as masses of hyaline cartilage. And the chondrocytes, the cartilage cells, again, these have differentiated, enlarge, the lacuna grow, the matrix breaks down, the chondrocytes die, and the osteoblasts then go in there and deposit bone. And this forms the spongy bone, and then finally the compact bone. All right. Okay. Now, in terms of the endochondral long bones, again, you have a primary ossification center. This is the area in the center of the diaphysis where that bone tissue first replaces the cartilage, and then that replacement proceeds down towards the end of the bone. And then you have the secondary ossification centers. These are the areas at the ends of the bones in the epiphysis, where the spongy bone forms later in development, and the band of cartilage between these centers is called the epiphyseal plate, and we can see this in our little humans. All right, so you can see this occurring, and you see that little plate, and you can see definitely these plates right here in the baby, in the child's. Okay, so you get growth at the epiphyseal plate. And here's where you get osteoclasts and osteoblasts. So we have to explain this. There are different kinds of cells, and osteo means bone. Blast, we already said, were the young bones. Osteoclasts are cells that break down the matrix. So we talked about how we use the bone marrow and the two hormones to regulate calcium levels. So, and I said that we could break down the bone and release the calcium into the bloodstream, or we could take the calcium up and make new bone. The cells that are doing that are the osteoclasts and osteoblasts. So the osteoclasts break down the calcified matrix, and that's how that calcium gets released out into the bloodstream. And if we have plenty of calcium around, we're going to lay down new bone, and that's going to be done by those osteoblasts. So they invade, they replace that cartilage with the bone tissue. So osteoblast, new bone, osteoclast, they're breaking down that bone. All right, so the bone will continue to grow in length as long as the cartilage cells of that epiphyseal plate remain active. And when those centers meet, the epiphyseal plate ossifies, and bone can no longer grow in length. That's why we stop growing in height. All right? And that's really what is happening. All right, so as I mentioned, we have this homeostasis of making bone, breaking down bone. We are constantly doing what's called remodeling, and this goes on throughout life. This is a process of breaking down and making new. So the removal of the bone, again, by the osteoclast, the deposition of new bone by osteoblasts, and believe it or not, about 20%, 15-20% of the skeleton is replaced every year. So you're making a new bone, new skeleton, about quarter of your skeleton every year. All right, so that's it. And what I'm going to do is take you into the lab, and we're going to take a look at some of these actual bones, and I'm going to go over the names of the bones and the nooks and the crannies so that you can learn them for the test.